Hello students, myself Dr. P. Shekar, Assistant Professor in Department of Mathematics, VNR JYOTHI Institute of Engineering and Technology, Hyderabad. So today we shall discuss basic differentiation problems which are more popular in engineering mathematics and in particular ordinary differential equations and vector calculus. So what is differentiation? Differentiation is our derivative measures how a function changes, like speed telling how position changes over a time. So this you have already seen differentiation formula in derivative of f of x or f dash of x is equal to limit delta x tends to 0 or dx tends to 0 f of x plus delta x dx minus f of x by delta x. So the rate of change of f with respect to x. So now let us understand basic formulae which are useful in differentiation. So first one among them is a power rule. So what is the power rule? Suppose the function is given to be in the form of f of x to the power n, then derivative of f of x as n into x to the power n minus 1. Suppose we have an example of f of x is equal to x cube. Then derivative of x cube as 3x square. Derivative of x square as 3x square. So this is simple. And similar to it, no, for any integral power, whether it is x power 4, x power 5, x power 6, something like this, we can get the integration just by replacing n by with respect n by 3 or 4 or 5 likewise. For instance, if I have f of x as x to the power minus 3, then f dash of x. So in place of n, it is to place minus 3. So even it is same for negative integer power. So it has minus 3 into x to the power 3 minus 1. So this is minus 3 into x to the power minus 4. Or equivalently, you may write it as minus 3 into x to the power minus 4 as into 1 by x to the power 4. Or this is 3 divided by x to the power 4. So this works same as for positive integer. So whether n is positive integer or negative integer, it remains same. So in the previous example, x cube, it is 3 into x to the power 3 minus 1. Now it is minus 3 into x to the power minus 3 minus 1. So it becomes x to the power minus 4. So it is 3 into 1 by x power 4. Nothing but 3 by x to the power 4. Likewise, if I have the function f of x as root x, or root x is equal to x to the power 1 by 2. Now what is n? N is equal to 1 by 2 as a fractional term. So then f dash x will be 1 by 2 into x to the power 1 by 2 minus 1. So now n is 1 by 2. So it is 1 by 2 into x to the power 1 by 2 minus 1. 1 by 2 minus 1 is minus 1 by 2. Or which is 1 by 2 into x to the power minus 1 by 2 means 1 divided by root x. So basically derivative of root x is nothing but 1 by 2 root x. Likewise, let me take one more instance, one more example where I have considered f of x to be 1 by root x. So equivalent to it, what we can write, x to the power minus 1 by 2. X to the power minus 1 by 2. For root x, it is x to the power 1 by 2. For 1 by root x, it is inverse to it. So that is why it is x to the power minus 1 by 2. Then the derivative, f dash of x is, now n is equal to minus 1 by 2. So n into minus 1 by 2 into x to the power minus 1 by 2 minus 1. This has minus 1 by 2 into x to the power minus 1 by 2 minus 1. Minus 1 by 2 minus 1 is minus 3 by 2. So or this is equal to minus 1 by 2 into x to the power minus 1 by 2 means 1 divided by x root x. So this is how we can see derivative of x to the power n, what is called power rule. So here in this case, n may be a positive number like 3, 4, 5, 30, 40, or it may be a negative integer -3, -4, -5, or it may be a fractional form 1 by 2 or 1 by 3, 1 by 4 likewise. In most of the engineering problems, we may see in fractional powers as well, x to the power 1 by 2, x to the power 1 by 3, x to the power 2 by 3, and even inverse power, as here in this 1 by root x, or x to the power -1 by 2, or maybe x to the power -1 by 3. So just applying the same formula where n can be replaced by 1 by 2 or 1 by 3, you will be getting the derivative correspondingly. Now the second one, when we have the function given to be a constant. So constant means it never changes, so there won't be any change in its value, so the derivative of that function is 0. So as an instant, one example, suppose let me take f of x as some constant. Here in this case it is 5, so derivative correspondingly is 0. So whether it is 5 or anything, if you find it as constant, then the rate of change or the derivative is 0. And the next one, which we see more often, sum rule. Sum rule is derivative of sum of the functions is nothing but sum of the derivatives. Suppose we have d by dx of f of x plus g of x, or f plus g. This we could write it as d by dx of f or f of x plus d by dx of g of x or g. Same lines, even if it is a difference of the two functions, we can write simply minus in between. Suppose it is d by dx of f of x minus g of x, then that will be equal to d by dx of f of x minus d by dx of g of x. For instance, let me take one example, a simple polynomial I just took consisting of 3 terms, namely x cube, 3x and minus 7, then derivative of f of x, which is nothing but f dash of x, is equal to derivative of x cube, that is what we have seen in the previous problem. It is 3x square plus 3 into derivative of x as 1, and minus derivative of 7 being constant, derivative of 7 is 0. So it is simply 3x square plus 3. Derivative of x square plus 3x minus 7 is 3x square plus 3. Let me take one more example. In these lines, I have f of x as root x plus 1 by root x. So root x, how could we write root x as x to the power 1 by 2? This also we have seen in the previous sum. And now the second term we have 1 by root x. 1 by root x as x to the power minus 1 by 2. 1 by root x as x to the power minus 1 by 2. So it is to differentiate x to the power 1 by 2 and x to the power minus 1 by 2 separately and sum up those two. So it will be 1 by 2 into x to the power 1 by 2 minus 1. And same lines plus, now what is n? N is minus 1 by 2. So minus 1 by 2 into x to the power minus 1 by 2 minus 1. So this comes out to be 1 by 2 into x to the power 1 by 2 minus 1. 1 by 2 minus 1 is minus 1 by 2. Plus into minus 1 by 2 into x to the power minus 1 by 2 minus 1 is minus 3 by 2. So derivative of root x plus 1 by root x as 1 by 2 into x to the power minus 1 by 2, or you may write this as 1 divided by 2 root x plus derivative of f of x, f dash of x as 1 by 2 root x plus, plus it is minus, so it is minus derivative of 1 by root x as 1 by 2 into x to the power minus 1 by 2. What is x to the power minus 1 by 2? 1 divided by x root x. So this is what the derivative of root x plus 1 by root x. Same lines, number of terms may be any. So in the first example, we have 3 terms, x cube, 3x and 7. In the second example, we have 2 terms, root x and 1 by root x. Number of terms may be any. In order to differentiate such a function, sum of number of terms can be differentiated separately and we can sum up. Okay, and the next one, one more popular formula that we're gonna use in differentiation is product rule. Product rule as f of x is equal to u into v. Further, u and v are functions of x. Then derivative of f of x as u dash v plus u into v dash. You may write these terms in reverse. I mean, you may write u into v dash plus u dash into v. However, let me consider one instance, one example where f of x is equal to x square. Then its derivative f dash of x is equal to u dash derivative of x, which is 2x, v sin x plus u being x square as it is, and derivative of sin x cos x. So it is 2x into sin x plus x square into cos x. U dash v plus u into v dash. Whatever the derivative term, whether it is u dash or v dash, I just represented through flower brackets. Likewise, let me take one more instance where the function is e power 2x into sin x. Then the derivative f dash of x, just by applying same rule, u dash v plus uv dash, u dash derivative of e power 2x. Derivative of e power 2x is 2 into e power 2x. Derivative of e power 2x is 2 into e power 2x. V as it is, sin x plus now u being e power 2x and derivative of sin x. Derivative of sin x as cos x. So this is one more example. Let me consider one more of this kind where I have f of x as x cube into log x. Then what happens to that f of x? Derivative of f of x, nothing but f dash of x. Same lines, derivative of u. Derivative of what is u? U is x cube. So derivative of x cube is 3x square, and v as it is log x plus u into x cube into derivative of log x, 1 by x. Or you may also rewrite this as 3x square into log x, 3x square into log x plus x cube by x, nothing but x square. This is how we can find the derivative of product. What do we call? We call this as product rule. So this can be extended even when we have more than two functions. Suppose if we have product of u and v and w, derivative of this product as u dash into v into w plus u into v dash into w plus u into v into derivative of the third function, I mean w. So likewise, even for three functions also, this can be used. But mostly we look into derivative of product of two functions most of the times, but the same can be extended for three functions as well. Just as we do in the case of function of product of two functions, same lines it can be extended for product of three functions. And one more popular result or formula that we're gonna use here in differentiation is derivative of u by v. What do we call? Quotient rule. So if f of x is in the form of u by v, then derivative of f of x is nothing but v into u dash minus u into v dash divided by v square. U being the numerator, v being the denominator. Then the derivative is going to be in the form of u dash v minus uv dash divided by v square. For instance, let me take an example of f of x is equal to x square plus 8 divided by 2x minus 7. U being the numerator, which is nothing but x square plus 8, and v is nothing but denominator, which is 2x minus 7. Then the derivative of f of x, which is nothing but f dash of x, is equal to u dash derivative of x square plus 8, which is 2x, and v. What is v? It is 2x minus 7 minus u into u being the numerator, it is x square plus 8 into v dash, derivative of 2x minus 7. Derivative of 2x minus 7, it is 2 divided by v square. V square means square of the denominator, 2x minus 7 whole square. So this is to be simplified further. So 2x into 2x, 4x square, 2x into minus 7 minus 14x minus of 2 into x square, 2x square plus 2 into 8, 16 divided by the same, there is no change in the denominator. So it is 2x minus 7 whole square, or the same can be written as 4x square minus 2x square. It is 2x square minus, we have a linear term, first order term, 14x minus into plus minus 16 divided by square of this term, 2x minus 7 whole square. So what we have done, in order to differentiate this x square plus 8 divided by 2x minus 7, we applied quotient rule, which is u by v whole dash, which has u dash into v minus u into v dash divided by v square, u being the numerator, which is x square plus 8, v being the denominator, which is 2x minus 7. So as per the formula, u dash, derivative of numerator x square plus 8, 2x, and into v, which is 2x minus 7 minus u is x square plus 8, derivative of denominator 2x, it is 2, and square of the denominator, which is 2x minus 7 whole square. Simplifying, we are going to get this as 2x square minus 14x minus 16 divided by 2x minus 7 whole square. Just similar to it, one more example in these lines where I have f of x as cos x divided by x square. Then what will be the derivative? Then f dash of x. Now what is u? U is cos x, the numerator. What is v? Denominator. What do we have in denominator? X square. So in the same lines, u dash, derivative of cos x, which is sin x, v as it is x square minus u being cos x, numerator, and derivative of x square is 2x. Derivative of x square is 2x over v square, x square whole square, x square whole square, or this can be rewritten as x square into sin x minus 2x into cos x whole divided by x to the power 4. You may also cancel a common term x in both numerator and denominator. So after simplifying further, we can get it as x into sin x minus 2 into cos x. After cancelling that x, we are going to get this x cube in the denominator. So derivative of cos x by x square as x into sin x minus 2 cos x by x cube. So once again, it is the same, u dash into v minus u into v dash divided by square of the denominator. So as we have x square already, so square of x square is x to the power 4. And after cancelling the common term x, which is present both in numerator and denominator, it becomes this. You may also try these, and these are left for exercise. Just in same lines, you may differentiate sin x by x square, similar to the previous, 3x minus 4 divided by 2x plus 8, similar to the first one, and third and fourth in these lines. So these 4 problems are left for exercise. You can find the derivative using quotient rule. And one more popular result that we're going to see in differentiation, what is called chain rule. When we have f of x as g of h of x, when we have f of x as g of h of x, then the corresponding derivative f dash of x as, first it is to differentiate g of x, g of h of x as g dash of h of x, and further derivative of h of x as h dash of x. So it is like, in a chain, first f is a function of g, whereas a function defined in terms of g, whereas g in terms of h, and h is defined in terms of x plus. So in such case, if it is to get the derivative of f of x, first it is to get the derivative of g, and it is to differentiate the function h, nothing but h dash of x. Let us illustrate this with one example. Let me have one function f of x as sine of x square. Then its derivative f dash of x, then its derivative f dash of x. First derivative of sine function. Derivative of sine function, it is cos. So it is cos of x square. Further, differentiation of x square. Differentiation of x square is 2x. So first derivative of sine, which is cos. Further derivative of x square, which is 2x. Just in same lines, we have sine square x. So first example, it is of sine of x square. Now it is sine square x. Sine square x is same as sine x whole square. Hope you find these two different. Hope you understand these two different. First one is sine of x square. This one is sine x whole square. Then what happens to the derivative of it? So derivative of sine x whole square. Firstly, it is in the form of x square. What is derivative of x square? 2x. So derivative of sine x whole square is 2 into sine x. Further, derivative of sine x. Derivative of sine x as cos x. So what is derivative of sine square x? Derivative of sine square x is 2 into sine x into cos x, which is, as per the trigonometric formula, sine 2x. As you know, sine 2x as 2 sine x into cos x. As you know, sine 2a as 2 sine a into cos a. So the same we can write it as sine 2x. Just in same lines, let me consider one more example. In these lines, let me have f of x as log of sine of x. Log of sine x. So if it is to get the derivative of f of x, first it is to get the derivative of log function. Derivative of log function. What is derivative of log? Derivative of log is 1 by x. So it is 1 by sine x. Further, derivative of sine x. What is derivative of sine x? Derivative of sine x is cos x, which is nothing but cos by sine. What is cos by sine? Cos by sine is cot x. Likewise, we have one more of this kind, sine of log x. We have one more function, sine of log x. So derivative of it correspondingly, derivative of f, nothing but f dash of x. First derivative of sine. What is derivative of sine? Derivative of sine is cos. So it is cos of log x. Derivative of sine is cos. So derivative of sine of log x is cos of log x into derivative of log function. What is derivative of log? Derivative of log is 1 by x. So it is basically 1 by x into cos of log x. 1 by x into cos of log x. Okay. So this is how we can get the differentiation by using chain rule. So far what we have discussed derivative by power rule, sum rule, next product rule, and then quotient rule, and this one last chain rules. Okay, so these are popularly used in differentiating any given function, basically in ordinary differential equations and also in vector calculus, and these also occur in multiple integrals. When we transform one function to the other function, it is required to get the derivative of it. Okay, so few more problems for your exercise, for your practice using the same chain rule. One is f of x is equal to e power minus cos x. 2 is cos of e power minus x. And third one is square root of 1 plus x square. And fourth one, square root of cos of 3x minus 2. Okay. So hope you practice these problems and answer to these questions. Okay. So that is for today's session, today's class on basic differentiation. Okay. Right. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.